Now we'll enter into the digital communication, digital modulation schemes. Digital modulation schemes. The moment we come to the digital modulation schemes, again here here itself there are two varieties, say digital carrier modulation, digital carrier modulation, or otherwise pulse modulation. Or pulse, sometimes it is called as pulse analog modulation, analog modulation. Pulse analog modulation means I think mostly might have studied like a technique called PAM, PPM, PWM. Okay, PWM. These are all pulse analog modulation. Digital carrier modulation, or sometime you might have studied like digital passband. Digital passband modulation, or digital carrier modulation, or in general digital modulation. The moment they say digital modulation, in general, that is ASK, FSK, and PSK. ASK, FSK, and PSK. ASK, FSK, and PSK. But நம்ம டிஜிட்டல்னு சொன்னாலும் இதுலயும் அனலாக் இருக்கு. So again, mainly this will be used for long distance communication. All these technique will be used for long distance communication. Long distance communication. The moment you say long distance communication, definitely it involves analog carrier. Definitely it involves analog carrier. The moment you say long distance, definitely the techniques involves analog carrier. So now, what is the major difference between these two? If you observe carefully, between these two, in case of digital carrier modulation, the message signal will be digital. The message signal will be digital. Carrier will be analog. Why? Because it has to go for long distance. Whenever the signal wants to go for long distance, definitely the carrier must be analog. Or otherwise, whenever the signal wants to be transmitted over air interface, okay, free space, definitely the carrier must be analog. Okay, digital signal cannot travel on the air. Okay, only analog carrier can travel on the air, but somehow it is taking the digital information. That is the different story. But what we are doing here, in case of pulse analog modulation, PPM, PWM and all, here, if you carefully observe, message signal is analog, but carrier is digital. Please refer your basics. Okay, mostly you may be having confusion between these two methods. Okay, so this is the true digital carrier modulation, this ASK, FSK, and PSK. Now we are given with this syllabus only, that is they clearly mentioned about ASK, FSK, and PSK. Now we'll continue with this ASK, FSK, and PSK. So இதெல்லாம் போறதுக்கு முன்னாடி நம்ம some basics regarding the digital communication, like bit error rate, அதனுடைய basics இதெல்லாம் வந்து பார்ப்போம். So now mainly we are discussing digital modulation or digital carrier modulation. Okay. What is bit error rate? Okay, bit error rate. So நம்ம எவ்வளவு பிட்ஸை டிரான்ஸ்மிட் பண்றோம், அவ்வளோ பிட் தான் ரிசீவர்ல போய் ரிசீவ் ஆகும். பட் அதில் எத்தனை பிட் எரரா இருக்கு, that will come in the numerator. Number of bits in error, then total number of bits received. Mostly this term is with respect to the receiver, total number of bits received. எரரே எங்க கண்டுபிடிப்போம், ரிசீவர்ல தான் கண்டுபிடிப்போம். டிரான்ஸ்மிட் பண்ணும்போது ஒன்றும் ப்ராப்ளம் இல்லை, பட் ரிசீவர்ல கரெக்டாக ரீச் ஆச்சா, தட் இஸ் த கொஸ்டின் மார்க். So BER is always related with the receiver. So total number of bits in error divided by total number of bits received. எவ்வளோ பிட் ரிசீவ் பண்ணோம், அதில் எத்தனை வந்து எரரா இருக்கு. For reliable communication, BER must be at least 10⁻⁶. for reliable communication, BER is at least 10 power minus 6. இதை விட பெட்டராகவும் இருக்கலாம். Better means 10 power minus 7, minus 8, that and all allowed. But is 10 power minus 6. Okay, in every 1 million bits, 1 bit can be in error. In every 1 million bits, 1 bits can be in error. That is a relaxation. So what is the BER of optical communication? Nowadays, for data, fast data transfer, we will be using optical communication. Mostly, if you have a campus connectivity, okay, between the departments, definitely the internet will be given through optical network. Okay, between the department. That means from the administrative building for all other department, the connectivity will be made of optical fibers. Again, between the main station, say BSNL office or some other network provider. From that network provider also, we may be getting the signal through optical fiber only. Later on only, we are converting through that our ordinary LAN network, okay, ordinary with help of the wire. Within the department, we may have LAN connectivity, that is ordinary wire. But between the department, okay, between the department or from the administrative building, we'll be getting the optical communication network, optical communication. So why? Because that will support very high data rate, and also it is having very less error rate. So BER in optical communication is very low. BER in optical communication is very low. That is in the order of 10 power minus 9. That means every 10 power 9 bits, 1 bits can be in error. Then what is the definition of bit rate? What is the definition of bit rate? Number of bits transmitted per second. Number of bits transmitted per second is called bit rate. Then there is another term called baud rate. Number of signaling element, okay, or number of symbol. Some bookல symbol use பண்ணுவாங்க, or some bookல number of signaling element transmitted per second is called baud rate. Now you should know the difference between bit rate and baud rate. Like simple analogy சொல்றேன். நம்ம ஒரு இடத்துல இருந்து இன்னொரு இடத்துக்கு போறோம்னா பஸ்ல போறோம். அப்ப அந்த பஸ் வந்து நீங்க பாட் ரேட்டா கன்சிடர் பண்ணலாம். ஒரு பர்టిక్యులர் டைம்ல ஒரு பர்టిక్యులர் ரூட்ல say 1 hourல எத்தனை பஸ் கிராஸ் ஆகுது, how many number of buses are crossing, that is like a baud rate. இந்த பஸ் யார் இருப்பாங்க, peoples நம்ம தான் இருப்போம். That you consider like a bit. Okay, inside the bus people will be there. That is the bit rate. Okay, so if you carefully observe, mathematically baud rate will be always less than the bit rate. ஏன்னா ஒரு பஸ்ல மினிமம் 1 people ஆது இருப்பாங்க, இல்ல more than 1 people இருப்பாங்க. So mathematically baud rate in general, mathematically baud rate in general is less than or equal to bit rate. So that means what? Bit rate can be greater than or equal to baud rate. Again, there is some specific mathematical condition is there. The specific relation is there between the bit rate and baud rate. Later on I will specify, okay, depending on the type of communication or order of the modulation scheme, this relation will be defined later on. அதுக்கு முன்னாடி அடுத்தது நம்ம ஏஎஸ்கே பிஎஸ்கே இதெல்லாம் போகிறதுக்கு முன்னாடி we will see some of the basics, that is basis signal. So to define this ASK, FSK and PSK signal, I will be using some signal. That signal is called basis signal. So in general, it is having some of the properties. Okay, the basis signal must have unit energy. It must have unit energy. The energy in the basis signal must be unit energy. The next one is it must be orthogonal to each other. These are all the two basic properties of the basis signal. அதாவது என்ன சொல்றோம் அப்படின்னா, ஒரு ஆர்டினரி கோஆர்டினேட் சிஸ்டத்தை எடுத்துங்க, IJK யூஸ் பண்ணுவோம். What is the magnitude of I and J? Unit vector, unity. Again, they are orthogonal to each other. So similarly, in the communication domain, we will be using basis signals for defining the modulation schemes. There I have to use signals, but these signals have to follow these conditions. They must have unit energy, and then it must be orthogonal to each other. So now I will write one basis signal, say pi 1 of t. I am giving some new type of amplitude. Instead of putting a, I am giving some new value, say square root of 2 by tb, then cos 2 pi fct. I know what is cos 2 pi fct, that is a regular signal, but in amplitude I am putting something, some other values. Now I have to prove the energy contained in this signal is unity energy. And then now I have mentioned only one signal. Whenever the new signal comes, I have to worry about the orthogonality. இப்போ இதனுடைய எனர்ஜி வந்து 1 வருதா அப்படின்றத பார்ப்போம். How to find out the energy? So energy in signal is equal to power multiplied by the time. Power multiplied by the time is the energy. First of all, find out the power of this signal, that is whole square divided by 2, and then multiply with the tb, then the final answer will be 1. That's why I have written like this. Okay, so I have formed the basis signal in such a way that energy is 1. So now I satisfy the first condition. Then next condition, then how to choose pi 2t? Now I have to take another signal. They must be orthogonal to the first signal. So instead of cos, now I will put sine. So sine 2 pi fct. So mostly I will be using this signals pi 1 of t and then pi 2 of t as a basis signal for defining the modulation schemes, for defining the